Alright, implicit differentiation. This question has, question number 4 has 3 parts. Part A is just says verify the point P is on the curve C. Easy thing to do. And then in the second part we are asked to find dy over dx. It's also easy but a longer. There will be a lot to manipulate here. And then after that we need to find the normal to C at the point B that crosses the x-axis at the point Q. Okay, starting with the first one. If you want to justify, show that the point is on the curve, all you gotta do is substitute these coordinates instead of x and y. So if I put instead of x1 and instead of y2 in the equation, so the left hand side must be equals to 0 as the right hand side is 0. Alright, instead of x, I'm going to be writing 1, so that's going to be 3 multiplied by 1 squared, plus instead of y2, that's a 2 squared minus 4 times 1, and that's going to be multiplied by 2, plus 8 to the power of 1 minus 11. Let's see if this is equals to 0. That's a right hand, just left hand side, left hand side. 3 plus 8 minus 8 plus 8 minus 11. 8 is gone. That's basically 11 minus 11. That is 0. So that's how we justify it. So this point is on the curve. Okay. So the second part of this question is asked to find dy over dx. So let me copy the equation here first. 3x squared plus 2y squared minus, that's a 4xy, and plus 8x minus 11 equals 0. Okay. So all I'm going to do, I'm going to be finding the derivative of this, derivative of this, derivative of this, derivative of this with respect to x. Okay, so derivative of 3x squared with respect to x is going to be 6x. Derivative of 2y squared with respect to x is going to be 4y, but dy over dx. Minus, take the 4 out, and you're going to be finding the derivative of x and y. Let me write this, and that is 8 to the power of x. So that's going to be 8 to the power of x ln 8 with respect to x, and minus 11 will be 0. That's equals to 0. Okay, so that's a 6x plus 4y dy over dx minus 4 times, so that's a product. With respect to x is y, with respect to y is x dy over dx, and plus 8 to the power of x ln 8 equals to 0. That's a 6x and plus 4y dy over dx minus 4y and minus 4x dy over dx plus 8x ln 8 equals 0. Okay, I'm going to be keeping these terms in term of dy over dx on one side and taking everything to the other side. That will be 4y minus 4y, 4x, and then factorizing this as dy over dx, and then everything to the other side, negative 8x ln 8 plus 4y minus 6x. So the dy over dx is going to be negative 8x to the power of x ln 8 plus 4y minus 6x. That's divided by 4y minus 4x. Of course, you might gonna see a different rearrangements on this. That can be written as 4y minus 6x minus negative minus a to the power of x, ln y, and so on, like different arrangement. You can see it on this. Okay, so that's how we find the dy over dx. Okay, so that's an implicit differentiation. A and B are done, and then we're gonna go to the normal to the C at the point P. So the P has the coordinates 1 and 2, and the gradients we know from the top one is negative 8 to the power of x ln 8 plus 4y and minus 6x, that is divided by 4y minus 4x. So all we gotta do, we find that's a gradient of the tangent. That's a gradient of the tangent. We're gonna be finding using that the gradient of the normal at this point. So gradient of the tangent at this point, let me write it as t over here, is going to be negative 8 to the power of 1 ln 8 plus 4 times 2 8 minus 6 divided by 4 times 2 8 minus 4. That gives us 2 minus 8 ln 8 over 4, and I'm going to be simplifying this as 1 minus, dividing both by 2, 4 ln 8 over 2. That's the gradient of the tangent. So the gradient of the normal one is going to be negative 2 divided by 1 minus 4 ln 8, or you can write this as 2 divided by 4 ln 8 minus 1. That's also correct. Okay, so all we have to do now, and since the equation of the line is something like this, the gradient multiplied by x minus x1, let's say. So I need to know what's x1 and what is y1. Alright, and luckily we know all, because they say the normal at this point, like at the point P, and we need to find the x coordinate of Q, giving your answer in the form of this. So that intersect with the x-axis at the Q, we need to find the x coordinate. Okay, so what we're gonna do is like y minus 2 equals to 2 divided by 4 ln 8 minus 1. That's multiplied by x minus 1. I need to find the next intersection where the y is 0, which basically that's 0, which means negative 2 is equals to 2 divided by 4 ln 8 minus 1 x minus 1. Remember, I'm looking for x coordinate. I'm gonna be dividing both sides by 2 divided by 4 ln 8 minus 1, or multiplying both sides by 4 ln 8 minus 1. That gives us negative 2 multiplied by 4 ln 8 minus 1. Then I need to be dividing this one by 2, because there will be a 2 left on the right side. That's x minus 1. Then moving 1 to the other side. Let me just actually simplify this. I'm going to make it even easier. Make it 4 ln 8 plus 1. Remember, we have 1 over here. Let's add it to that. So then the x coordinate will be negative 4 ln 8 plus 2. And there's one more thing that we need to take care of over here, is they say a plus b ln 2. So as you can see, we have here ln 8. All we gotta do is write this as 2 cubed and plus 2, and then that's gonna be negative 12 ln 2 plus 2. Let's write it as they wish. So that is the answer. So this is the part where involve a lot of logarithmic, let's say, manipulations. So if you're now good at with the logarithmic problems, you should be first revising the logarithms.